Good morning to one and all. This is Dilip Kumar, Assistant Professor, Department of Computer Science and Engineering, Asakaya Engineering College, Bhimavaram. In this video, I am going to discuss about data encryption standard. Data encryption standard is an example for symmetric key cryptography. In previous video, we are discussing about symmetric key cryptography and block ciphers. The objectives of this video are to define basic structure of DES and the basic building blocks of DES algorithm, and to describe the key generation process, and to define working of triple DES and analyzes the advantages of triple DES over DES. Data encryption standard. The data encryption standard published by National Institute of Standards and Technology in 1977. The data encryption standard has been the most widely used encryption algorithm until 2005. It was proposed by IBM. It exhibits the classic crystal structure. It is a block cipher. Plain text block size is 64 bits and key size is 56 bit, and number of operations, rounds of operations are 16. DES encryption process. The two keys are input to the two inputs to the encryption function. The first input is 64-bit plain text and second one is the key. DES encryption follows electronic codebook mode. Here we are dividing the given message into 64-bit blocks. Those block is undergoing to DES algorithm. After that, it will give output as 64-bit ciphertext. All 64-bit ciphertexts are combined and finally we are getting the cipher message. In this diagram, it shows about the how 64-bit plain text converted into 64-bit ciphertext. The 64-bit plain text undergoing to initial permutation, then it is undergoing to 16 rounds of operations and finally inverse permutation, and it gives 64-bit ciphertext. Initial permutation. In initial permutation, the 64-bit plain text is transformed into the given matrices. Here we are taking all the positions of 64 bits from 0, 1 to 64. Here we are changing the positions from 0, 1 is changed to 58. The 58th bit is placed at first position, and so on. Inverse permutation. Inverse permutation is also called as final permutation. After completing the functions, we are finally undergoing to inverse permutation. In inverse permutation, the first position is replaced with 40th bit. It can be seen that the original ordering of the bits is restored. Details of single round. The 64-bit plaintext is divided into two 32-bit plaintexts. Those are left plaintext and right plaintext. Each round can be summarized in the following formulas. Here, the left plaintext and right plaintext. Right plaintext is undergoing to expansion, permutation, and S-box substitution and P-box permutation, and finally XOR with the left plaintext. It will become the right side plaintext for next round, and the right side plain text in previous round become the left side plain text for next round. Here these operations are key operations. Every time we are getting a new key from the 56-bit keys. For each round we are getting a new key. Key generation. A 64-bit key is used as input to algorithm. Every 8th bit is ignored. Here, every 8th bit is ignored. Then these 56 bits are divided into 28 bits. After that, they are undergoing to the some circular shift operations. Those left shift schedule are given here, and finally we are getting a 48-bit key. The 48-bit key and the right hand side input is 32-bit. We are expanding these 32-bit into 48 bits by adding expand means scaling of 16 of our bits. The result of a 48-bit expansion permutation XOR with Ki, and it will give 48-bit result which passes through substitution function. Here are 32 bits expansion permutation. Those are undergoing to 48 bit and key 48 bit, both are XORed, and this is called S box substitution. Here we are having the 8 S boxes, each one input as 6 bits and output as 4 bits. Finally we are getting the 32-bit text. Those 32-bit text input to the P-box permutation. This is the sample S box. In sample S box, the input is 6-bit. The first and last bits are we are taken as a row, and middle bits are we are taken as columns, and the resultant is 12. P-box permutation. The 32-bit output of S-box substitution is permuted according to the P-box. This P-box permutation maps each input bit to an output position. No bits are used twice, no bits are ignored. After that, we are applying the XOR and swap. In XOR operation, we are XORing with the left plain text, and after that, we are swapping the previous right plain text into left plain text for next round. The swapped output of 16th round is the input to final permutation. Final permutation is the inverse of initial permutation. And after that we are getting the 64-bit ciphertext. We are combining all these 64-bit ciphertext. We are getting a cipher message. Decryption process. It is a symmetric key cryptography. So by using this DES, we are encrypting or decrypting a block. The only difference is the keys must be used in reverse order. Triple DES. The DES key size is 56-bit key. So if you want to crack the 56-bit key, we are having combinations of 2 power 56. So it is easy to crack a DES key. That's why we are going with triple DES. In triple DES, we are having 112-bit key for 2 keys and 168-bit key for 3 keys. Here the DES with 3 keys, 64-bit plain text undergoing the DES cipher and DES reverse cipher, DES cipher. Finally we are getting the 64-bit cipher text. Here we are using 3 keys. And the decryption process is the reversible process of the encryption. Here by using the 2 keys, here we are using K1 and K2 and encrypted by using K1. So here plain text encrypted with K1, it gives a medium ciphertext A. This A is decrypted by with K2, it will give another ciphertext. Those ciphertext is encrypted by using K1, it will give the final ciphertext. This final ciphertext is in the reversible process in decryption. DES versus triple DES. The key size is 56 bits in DES and in triple DES 112 bit for 2 keys and 168 bit for 3 keys. Number of rounds of operations are 16 and number of rounds of operations are 48. Possible keys 2 power 56 and here 2 power 112 for 2 keys, 2 power 168 for 3 keys. Weaknesses: brute force and linear cryptanalysis easily crack the DES. Here also brute force and differential cryptanalysis, but somewhat secure than DES. Security is weak. Here security is inadequate. Number of keys 1. Here number of keys are 2 or 3. Summary: data encryption standard is a block cipher. It follows the Fichter structure and the function consists of expansion permutation and S-box, P-box and hexa and swap operations. Maximum number of atoms to crack DES is 2 power 56 and maximum number of atoms to crack triple DES is 2 power 168. Thank you.